Okay, so now sharing slides and starting the recording. So, as I said yesterday, we have finished all mandatory topics in our course. Sorry, just a moment. I have to recap, first of all, yesterday's lesson. So, yesterday we have seen the last part and second part of natural toxic substances. We have seen biogenic amines. We have seen that they are produced both by microorganisms during fermentation, but they can also be produced in plants mainly by plant physiology. Okay, so the main risk for biogenic amines is that of cardiovascular toxicity, in particular tachycardia and hypertension. So one of the big sources of this is bitter orange, that is often used in food supplements for weight loss. Very briefly, some information on mushroom toxins, and in particular on amatoxins, that are very, very dangerous and possibly lethal, or quite often lethal, and also thermoresistant. Then antivitamins, that are a subclass of anti-nutrients. We had already seen one kind of anti-nutrient, which were glucosinolates, okay? But in this case, this is an antivitamin. It is avidin, which inhibits the absorption of vitamin B7 due to the fact that it strongly binds this vitamin, okay? And this can cause mainly problems in the skin and in children, growth problems. Also, lectins are anti-nutrients. They strongly bind to sugars, and this can cause important damage to the mucosa of the intestine, leading to the loss of villi and thus a big sharp reduction in nutrient absorption. Lectins are mainly contained in different kinds of beans. Lectins are mainly inactivated by cooking, but some residue can still be there if the food is not properly cooked. Okay. Gossypol is contained in cotton seed, so the main source of problems can be cottonseed oil. It can cause an important hypokalemia, which is very dangerous. It can be fatal, since hypokalemia can lead to heart. Then we have seen some toxicants that are produced not by the plant themselves, but by microorganisms that can colonize different parts of the plants, and mainly fungi, so mycotoxins. We have 4 different classes, or main classes, of mycotoxins: aflatoxins, ochratoxins, patulins, and trichothecins. All of those substances are quite dangerous. Most of them can be carcinogenic and mutagenic, and all of them are not biodegradable and thermostable. So they can accumulate in the food chain, over the food chain, and they are not eliminated by cooking the food. Probably the most important ones are aflatoxins, and in particular aflatoxin B1, B2, G1, G2, and their metabolites, in particular aflatoxin M, which is a metabolite of B1 and is often found in milk. They are very, very poisonous. Okay? They are dangerous even at very low concentration, but in food we usually find even much lower concentration. So the real danger is not in acute poisoning, but in toxicity. And in fact, limits in the ppb, parts per billion range, are established for even lower for baby foods. Other ochratoxin, we have seen that the main host for those fungi that produce toxins are cereals. So great care should be put into assuring that cereals are correctly stored, since of course only, let's say it's mainly incorrect storage that can produce fungi infestation and thus toxin production. Okay, we have seen that ochratoxin can cause cancer, kidney failure, and abortion. Petrolanes, enterotoxicity, neurotoxicity, and again carcinogenicity. And trichothecins, it has a four-stage toxicity, including enteric inflammation, leukopenia, rashes, and anemia and immunodeficiency. So generally problems in generating blood cells, white and red, both white and red blood cells. Finally, zearalenone it's probably, let's say, the least toxic mycotoxin we have seen, since it is just, okay, in brackets, it's just an EDC. It has estrogen-like activity. You may remember that when a molecule has this kind of structure with two oxygen atoms, more or less at this distance, at 4 rings distance, it is similar to estrogen, so it can produce the same effects or similar effects. And in this case, zearalenone is, of course, it's not exactly specific, but it is most frequently found in corn. It's produced in corn, of course, again by microorganism, by seeds. Okay. Okay. So then we have seen natural toxins in foods from animals. Normally, they are not naturally present in those animals, or better, it's not the animal itself that produces toxic substances, but it is some kind of parasite or a symbiotic being that produces this kind of toxicant. Phycotoxins are produced by microscopic algae, and we have seen ciguatoxin. Ciguatoxin has gastrointestinal and neurologic effects. Again, just like mycotoxins, is thermostable, and it is lipophilic, so it accumulates, of course, in the fat parts of mainly of fishes, of course, since it is produced by algae. And then we have seen other 3 kinds of phycotoxins: domoic acid, which is amnesic poison; saxitoxin, which is a paralytic poison; and ocadaic acid, which is the diuretic poison. Tetrodotoxin is produced by a symbiotic bacterium within fishes of the Tetrodontidae family. So from this came the name. And the most well-known member of this family is the pufferfish, which is widely sought after in Japan. And the bacterium produces this toxicant in the ovaries, in the liver, the guts, and the skin. So all of these parts have to be carefully eliminated without contamination of the other parts before eating the fish. And it is, of course, quite difficult. You have to have a license in order to carry out this procedure. And it is, let's say, a high danger food, since there's no known antidote, and again, the poison is thermostable. And toxicity is muscle paralysis, which can result in breathing muscle paralysis, so death by suffocation can happen. Scombroid poisoning is not a natural event. It is produced during, scombroid poisoning happens when the fish is not properly stored, and it is due to the production of histamine from amino acids, and in particular from histidine, which is, of course, an amino acid, so it is present in high amounts in meat, meat and fish meat, of course. So many kinds of fish meats can produce this kind of poisoning, and we have seen that the symptoms are identical to the symptoms of allergy, since histamine is exactly the compound that is produced during allergic reactions, and so the symptoms of allergic reactions are exactly the same and due to the same substance than scombroid or histamine poisoning. I think this was all. Okay. So yesterday also we have had Professor Michele Protti give a lesson on the TOXOER project and how you can participate in the project and hopefully acquire more knowledge on toxicology, let's say in a more pleasant and active way of learning. It is an experimental project, so you, of course, you are welcome in taking it, and before you sit the exam, this exam of this course, you should take one at least. Of course, you can always take more, okay? You should take at least one of the topics of this TOXOER course and send me the results of the final survey, the final questionnaire, okay? So this was everything for yesterday. Now we have finished all mandatory topics. So today I will tell you something about one or two, let's see how much time we have, topics that are not mandatory, they are optional. Okay, so you will not find any question in the exam about this topic, ecotoxicology, nor about the other topic that we could, I'm not sure, but we could see today, which is the other toxic elements we have not detailed before. Okay, so ecotoxicology regards, let's say, wide-ranging aspects of toxicology. We have seen until now, all the topics we have seen, we have concentrated on the individual effects of pollutants, mainly concentrated on them, since, of course, for example, we have tackled problems regarding greenhouse effect and global warming, ozone depleting, and so on. But mainly we have seen the effects on single organisms, okay? So what the organism is experimenting when it is intoxicated with some poison. Ecotoxicology deals with the global effects of pollution, of contamination from toxic substances, and the dynamics of what happens once those toxicants go into the environment, okay? So let's say it's the big picture. In general, there are 4 pathways into ecosystems for poisons, and 3 are quite obvious, which, since they are the main constituents of the let's say of the environment, what we call the environment, okay? So water, soil, and air, okay? Everything we know is made of water, food, or air, okay? Sorry, water, soil, or air. But we also have a 4th pathway, which is food. So some part of the environment that is transformed into food for humans or for animals, okay? Of course, we have herbivores, for whom food is are plants, and we have carnivores, for whom food are other animals, and so on, okay? So let's take a look at each of these pathways. For pathways into water, the main source of contamination are, of course, anthropogenic sources, and in particular 3 main classes of sources: industries, okay, so production plants, and sewage, and of course sewage can be both treated or untreated. Nowadays, sewage shouldn't never go, let's say, be dispersed into the environment without being treated. But unfortunately, this is just a should. It is not doesn't, okay? So unfortunately, even now, we have untreated sewage going into the environment, and in particular into water, okay? And sewage, even if it is just organic sewage, okay, even if there's no important artificial synthetic toxicant within it, since it is simply let's say discarded organic matter, okay, it can be toxic due to the fact that in order to be degraded, it consumes a lot of oxygen, and of course consuming oxygen in the water means that fishes cannot breathe anymore. So this is very, very dangerous, even if there's nothing toxic in itself within sewage, okay? And also sewage sludges, sewage sludges are what remains after sewage has been treated. In line of principle, this should be just some organic matter, not particularly dangerous. However, again, these materials can be sprayed on fields just to dispose of them or to work as to improve the terrain for cultures. However, again, part of this organic matter can go into the water, and of course, again, it can consume oxygen and so on. And the two most important water bodies we can consider when considering pollution are surface waters. Of course, surface waters is what we see every day, okay? So rivers, lakes, the sea, and so on, okay? Glaciers. And once the toxicant goes into surface water, of course, it remains there, okay, especially in the sea. And this is a very important repository of toxicants. And of course, the big damage is done to aquatic. You may remember the famous poisonings of Minamata Bay regarding mercury, and of course, not only aquatic animals, but feeds on aquatic animals. But of course, another important part of water is groundwaters. So the water we don't see, especially if they are not deep, if we have shallow groundwaters, or the part of water which is included into soil, of course, this can be more easily contaminated from what, for example, is spread over the soil. And from these shallow groundwaters and from the soil, the toxicant, the contaminants can go to the plant roots and be absorbed by plants. So even plants can be contaminated by water contamination, okay? Also, it is possible to contaminate plants by watering plants with contaminated water. So this is another important source of contamination. Regarding food, as you may imagine, the most important source of contamination are pesticides, herbicides, and other kinds of, let's say, additives that are used in order to improve cultivation and improve the yield of crops, okay? And of course, these can remain on plants, but also on soil, and then be absorbed by plants, okay? So it's a vicious circle. And of course, from food, the connection is immediate to animals and to humans, also including possible bioconcentration along the food chain, okay? Regarding soil, of course, we have just seen that an important source of contamination are pesticides and similar treatments for crops. Also, be aware that not only direct contamination of soil from treatments can happen, but also indirect contamination from plants. Since when plants are treated, of course, if they are harvested and taken away, they don't contaminate the soil anymore. But whatever remains, if it is contaminated, stays in the soil, and it is in fact incorporated into the soil, and so it can further contaminate it. Also, air pollutants can contaminate soil, since we have seen that in many cases those pollutants are not gaseous themselves, but they are particles, or they can be absorbed on particles. And in time, even small particles can, let's say, precipitate, okay, can go down into the soil, and of course, this means that soil becomes contaminated with those substances and those particles. Another important source of soil, of course, in a very severe way, if improper disposal happens, we have seen at least a few times how chemical plant landfills have been reused for other purposes without decontamination. Okay, and this, of course, is very, very dangerous for man, for animals, and for the environment in general. But also, industrial wastes, if they are not correctly stored, for example, they can be washed down into the soil by water, by rain, and so on. If they are not accurately covered and, let's say, airtight stored, with wind and I don't know, simple air, they can blow off in other parts, and again they can settle on soil. So let's say that the industrial wastes can be blown off by winds and become, in all regards, air pollutants that can settle on soil. Whereas by air pollutants, usually we mean, for example, what is produced during fuel combustion and similar activities. Okay. When the contaminants go into the soil, we have a very close relationship between the soil and plants and animals. Of course, plants grow into the soil, and also they always stay in the same place. Okay, so if some soil is contaminated, all the life cycle of the plant will happen within contaminated soil. Okay. But also animals, even if they move, okay, they can move. Of course, they are in close contact every day with the soil. So widespread pollution of the soil can impact very, very strongly also animals. Air, we have of course, a lot of industrial sources and engines, in particular fuel engines, where we have a production of pollutants, and even tough nowadays, let's say that you shouldn't be able or shouldn't be allowed to release important amounts of pollutants from those sources, and in particular industrial sources are heavily regulated regarding the volatile and gaseous pollutants they can release. Of course, this is again not easy to monitor, let's say for every single producer, okay, and even if most pollutants are entrapped or not released into the atmosphere, however, some amounts are, and so summing up every producer of air pollution, of course, this becomes even minimal producing means that the total amount becomes quite large. And in this way, organic compounds, inorganic acids, just like nitric acid and sulfuric acid, we have seen before in inorganics, and heavy metals can reach air and stay there for a long time. And once all of these compounds are in the air, several atmospheric processes like photodecomposition, like let's say heat, can produce secondary pollutants, so modifications of the pollutants themselves that can be as dangerous or even more dangerous than the initial ones. And of course, all air-breathing animals, so of course from air contamination, fishes are excluded, and general aquatic animals are excluded, since they are breathing oxygen in water, and plants also are, of course, impacted. However, please pay attention that, of course, from the air, the pollutants can also go into the water, okay? Since, of course, air is in close contact with superficial waters, okay? So, under this regard, of course, even aquatic animals are impacted by air pollution. So those are the most important pathways for pollutants to go into the different ecosystem. However, we have seen, we have just he had just said so in the last over the last slide, but we have, of course, a lot of transfer between ecosystems. So once a pollutant follows one of the previously seen pathways in order to reach one of the targets, of course, the pollutants can go from one to the other. There's a heavy mobility between the different ecosystem and different targets. So, for example, from the soil, the pollutants can get dissolved into groundwaters and go into the hydrosphere. And of course, from the hydrosphere, it can go toward animals in the biosphere. And the critical parameter to go from one to the other, from water to animals, is, as we know very well at this point, lipophilicity. Okay, the more lipophilic the compound is, the more easily penetrates living tissue from water, in particular, since water is not lipophilic, so the compounds will tend to go elsewhere. And on the opposite side, from soil to water, it is hydrophilicity that drives this phenomenon, since, of course, to go into the water, it is better if one is hydrophilic. But we have, for example, evaporation from the ground or even from the water to the air, and so on and so forth. Okay, and this mobility not only let's say spreads contaminants and pollution locally from one system, let's say here in Rimini, where I am, from the soil in Rimini to the air in Rimini. But once the volatile toxicants evaporate in more warm climates, so let's say in warm parts of the world, they can be transported everywhere, and then when they reach colder ones, they will condensate and go down into the soil, into the water, and so on. So big movements of contaminants can happen in this way, and in particular, this can contaminate places that normally are not contaminated. You may remember that the polar ices are nowadays subject to increased contamination. This is one of the most important mechanisms that volatile pollutants evaporate in warm and temperate climates, and then the poles they will condensate due to the temperature. Okay, but also you may imagine, for example, that once a polluting compound goes into a river, it can be transported into the sea even very far from where it has entered the hydrosphere. Okay, are not only an important source of local spreading of pollution, but also of diffused pollution over the, let's say, entire environment, over the worldwide environment. Okay? And then when the pollution, when the contaminants get into the environment, they can damage living beings using not by a phenomenon which is called biotransfer. So the transfer of pollutants, of contaminants from the environment to the living beings. Okay, we know that usually the most dangerous substances are lipophilic ones. So of course biotransfer happens in higher amounts in organisms that have high lipid levels within them. Okay, and in particular, absorption is greatly enhanced if the site of entry, so the point of contact with the contaminant, is high lipid tissue. So, for example, we have the gills of fishes, the lungs of air-breathing animals, the gastrointestinal system, and the skin. All of these systems are highly lipophilic, and so they are especially good, let's say, at absorbing lipidic or lipophilic compounds. Also, the shape of the molecule and its size plays an important role. You may remember when we spoke about microplastics, but this is a general concept. So the smaller the molecule and the more spherical it is, and the better it penetrates into the tissues through small holes or in any way through channels, okay, cell channels within membranes and so on. Usually, so of course in this case we have an inverse relationship between size and penetration. Of course, no, smaller size means high penetration. Also, binding to particulate can reduce toxicity, since particulate can precipitate and so go out of the system. But again, we have seen that this is not so dry cut, since it can happen that particulates are quite small, so they penetrate lungs and so on. One exception to the high lipid, high absorption rule is extreme lipophilicity, since extreme lipophilicity means that you have no water solution, solubility, and so no water solubility means that the compounds are not transported, for example, in water towards fishes, but also in during digestion. Okay, if something is completely not water soluble, it cannot go into the water, which is the main, let's say, the main way to be absorbed by the intestine. Okay, so in this case, extreme lipophilicity means lower toxicity. And this is just an example of the different routes and the different let's say, amounts involving a lipophilic toxicant for an aquatic organism. We can see that from the sediment, the lipophilic toxicant can go into the water body and it will stay separate since it is lipophilic. So just as a tiny amount will go into the water since it is lipophilic. However, once it goes, even in small amounts in the solution, in the water, of course, all of it will go to the lipid tissue of animals, of fishes there. So this is obvious since the fishes, in particular the gills and the skin, are heavily lipophilic. So the substance, which is attracted by water, but it is attracted by the lipid tissue of the living being. And the opposite direction is, of course, not so important, since again for the same reason. Okay. Okay. Now I think we can stop here for the first hour. Is there any question? It doesn't seem so. No one is asking anything, so we can stop here and see you in 15 minutes. Bye. Okay, we are back. And sharing the screen. Okay, so we have seen the different means used by pollutants, by contaminants to go into the environment, to stay there, to be mobilized through different parts of the environment. We have also seen before that a lot of pollutants can be persistent pollutants, so they will stay in the environment for a lot of time, maybe in their original form or as their metabolites, biotransformation products, and so on. Okay. However, fortunately, also biodegradation can happen. So as soon as the toxicant goes into the different system regarding plants, animals, and the soil, there it can encounter a lot, really a lot of different microorganisms which can produce changes into its structure. And of course, changes means that the substance can get activated, as we know very well, okay, but it can also be deactivated and so become a pollutant no more, okay, so something not dangerous, not toxic, okay. Usually, microorganisms carry out just small changes to the molecule, but since there's a lot of microorganisms, those small changes will accumulate over time, since the product of the first change will be the substrate of another change by, for example, another strain of microorganisms, and so on. So those changes will accumulate and will produce smaller molecules. Usually microorganisms break down big molecules in order to produce smaller molecules. And those molecules are more similar to what you could already find in nature. Okay, so they are less dangerous, less poisonous. Okay, and in the end, if those smaller molecules are farther broken down and degraded, we can reach mineralization. This means that all organic matter is transformed into carbon dioxide and water, and the inorganic part is transformed into salts. Of course, salts can be toxic, but not all of them, of course. Okay, and when we talk about all those changes carried out by microorganisms, we always have to keep in mind that the total mass of microorganisms is huge. Okay, it's many times higher than the total mass of all other living beings together. Okay, so we have a huge diversity of strains, of species of microorganisms, and the, let's say, infinite variety of different species and strains often live one near to the other or in the same space. Okay, so they can have synergistic activity. This means that the activity of 2 or 3 or 4 different species not only sum up to produce this effect of degradation, but can multiply their activity. So if one species alone degrades 1 gram of toxicant, 2 species together will not degrade just 2 grams, but for example 20 grams, okay? Or produce a much faster degradation, okay? Since each species, each strain has different metabolic pathways and different enzyme systems. So they can cover most organic and inorganic structure and can degrade practically everything. Okay, in particular, since microorganisms are very exposed to mutations, and due to the huge number of microorganisms, even if most of them die due to pollution, for example, in a site, the small number of mutated microorganisms which survive will go through metabolic adaptation. So the strains that survive, of course, are those that resist to pollution, to the specific contaminant. And so these microorganism can degrade, can biotransform this compound in a better way, since, of course, they survive. But also, they can develop specific enzyme systems and metabolic pathways adapted to specifically degrade, specifically break down that pollutant. So let's say that each environmental zone which is polluted can develop microorganisms that are specifically adapted, let's say evolved in some way, with specific enzyme systems targeting the polluting substances in that place. Okay, this is very important and very useful for all living beings and for all the environment. Also, we are often conditioned to think about microorganisms, and in particular about bacteria, as dangerous bacteria for our health. But given the almost infinite variety of bacterial and other microbial species, there's many more useful bacterial species that can break down pollutant than dangerous species for our health. Okay, and in particular, microbial cells are quite good at two transformations. So the transformation of organic pollutants that are oxidized within the cell. So in the end, let's say complete oxidation will produce carbon dioxide and water. And the other important, let's say, specialization of microbes is the biotransformation of electrophilic pollutants. You may remember that electrophilic are those that contain a lot of electrons, of electron pairs, of free electron pairs, and in particular those containing chlorine. Okay, so microbial cells are very good at deactivating halogenated compounds. And we know that the halogenated compounds are a very big source, a very toxic source of pollutants. So those are two cases, but let's say that bacteria can be adapted or can adapt themselves better to almost any environment. And this is very useful for heavily contaminated places or locations. Also adapting to extremes of salt presence, of salinity, of temperature, very high or very, very hot or very cold temperature. Some bacterial species can be adapted to degrade plastics, for example. So this can be seen in the future as a good source of plastic elimination, okay, through mechanisms that go in the direction of biodegradation, in particular by microorganisms. Also, petrol oil-eating bacteria are well known, and they can be used to decontaminate oil spilling, for example. So, when we exploit biodegradation in order to decontaminate some site, some location, we can call it bioremediation. It is a practice that can be carried out mainly on soil. In fact, when contaminants go into the air and water, it is extremely difficult to decontaminate them, to bioremediate them. Okay, since of course water and air are much more mobile than soil, so contaminants can go a long way away through those media, and also they are very fastly dispersed in those media. Okay, of course it is possible to, for example, treat sewage, okay, since it is a closed system where just a controlled amount of water flows in the system. Okay, so this is perfectly bioremediable, let's say. Can be subjected to bioremediation, but it is a peculiar case. Okay, it is much more difficult to bioremediate air and water with respect to soil. We have two main kinds of bioremediation: in situ bioremediation and ex situ bioremediation. And as you can see from here, a lot of different kinds of techniques have been developed. Of course, in situ means that the bioremediation occurs to the soil right in the place where it has been contaminated. While for ex situ, we have to take away all the contaminated soil, transport it to some other place, and then bioremediate it in that other place. Of course, ex situ bioremediation is much more work intensive, and let's say it needs a lot of different organization and planning steps, since you have to take away a lot, express this weight, a lot of soil. Okay. So here we can see some examples of bioremediation. This is bioventing, where you can see that this in dark brown is the contaminated part of the soil, and with this technique you have biostimulation. So you inject nutrients for microorganisms in the soil, into the soil, and also you inject air through small wells here and here, and this air can circulate within the contaminated soil and go away back through other wells. Okay, and of course the air that comes out is potentially and also probably, very probably, contaminated, and so it must be filtered, usually through activated coal, which absorbs, let's say, unspecifically most organic compounds. So in this, of course, this is an in situ bioremediation, and of course this must be carried out above groundwaters. Okay, otherwise, this is, as you can see here, we take advantage of naturally existing microorganisms in the soil, and we stimulate their activity through air and nutrients. Okay, and similar techniques, but in this case involving groundwaters, is biosparging, where you practically inject just water and some nutrients through wells directly into the water, and from the water, the air and in part nutrients will go into the above soil. This can be done, for example, if you have contamination in contact with water. So already water is contaminated since there's contact there. And so you can also stimulate microorganisms directly into the water, okay? So both in the water and into the soil. And also bioslurping. In this case, it is mostly useful for hydrocarbon contamination. And hydrocarbons, since they are less dense than water, they float on water. So this is the groundwater table, and this black line is the hydrocarbon layer over water, since it floats. Okay, so in this case, again, we have the injection of air, and also let's say a movement of hydrocarbon, since air is drawn through this system, okay, and by aspirating air through the system, we make, let's say, we draw with the air also a flow of hydrocarbons, and since they are on the surface, so the air will flow over the hydrocarbons and it will draw them on the water, okay? And then at the end, the hydrocarbons will arrive into this well, and from this well it will also be aspirated into a let's say treatment, water and hydrocarbon treatment system, okay? But also the movement, it's not needed that it is only hydrocarbons. It can be also water, but the important thing is that the hydrocarbon, even if it is mixed with water, arrives here, and from here it is aspirated and it can be separated from water. Also, bioaugmentation is interesting. In this case, you don't use the naturally present microorganisms in the soil, just like here and here. You directly inject the microorganism there, and this is quite interesting, since you can choose which kind of microorganism to inject. So you can choose the best one, specifically targeted toward the contamination site, okay? So the most active microorganisms toward the specific substance, polluting substance. Of course, this needs a lot of microbial cultures, okay? So initially it's quite expensive, since you have to produce a lot of microorganisms in order to inject a significant amount for the huge tons amount of soil to be decontaminated, okay, or bioremediated. In this case, microorganisms are already in the soil, so you don't have to inject anything other than some nutrients. In this case, you have to use nutrients to produce a lot of microbes, or a lot of microorganisms. And then those microorganisms will very efficiently process the toxic and the polluting substances, since they have been expressly chosen for this purpose. Also, phytoremediation can be envisioned since many plants have the property of absorbing several kinds of pollutants from the soil, from the water, to the groundwater in soil, and even from the air, and they can process them and biotransform them. Of course, this is not, let's say, a generic bioremediation form. It is called, of course, phytoremediation, since plants have more limited biotransformation systems in comparison to animals, but it can be quite effective. In some cases, the plant is able to degrade, to biotransform the contaminant, and this, of course, can lead to the production of non-toxic substances. And this is probably the best case, okay? But the plant can also be able to absorb, extract the pollutants from the soil and water, and to accumulate, to store them into the plant itself without modifying them. So in this case, the plant will become in turn contaminated. Okay, so in this case, where there's no important degradation, the plants will have to be disposed of in some way that is not dangerous from the environment. So this is, of course, not optimal. Okay, but it is important since just one plant can decontaminate, let's say, 1,000 or 10,000 times its weight in soil. Okay, so you can phytoremediate, let's say, 1 ton of soil using 1 kilogram of plants. Okay, so it becomes concentrated into the plant. The contaminant will become concentrated into the plant. So you will have to treat and to decontaminate a much smaller amount of plant in comparison to the amount of soil you would have to treat otherwise. Okay. Okay, all of these are in situ bioremediations. Remediation systems. Okay, so you go to the site that has been contaminated and try to decontaminate it directly. Okay, in other cases it can be used, ex situ bioremediation can be used. So you go to the contaminated site, you take away all the contaminated soil, okay, or as much as possible, and then bring it to somewhere else, and you treat it directly. For example, slurry phase bioreactor. Here you have the contaminated soil, and you mix it quite strongly, but also injecting water. It is immersed into water, and you stir the sludge and the water together, also with air injection, also inoculating microbes in order to have, again, bioremediation, just like we have seen before. The advantage in this case is that the amount is heavily controlled, okay, so you don't have any leaking here, while the microorganisms are remediating, the soil can leak its contamination in other places. It can further contaminate underground water and so on and so forth. Here you have a very controlled system. This, of course, is a watertight container. Of course, it is very big. And so, in this case, you have a controlled system where you can let bioremediation happen. And also you need a limited amount of microorganisms, since you only have to inject them in this limited place. Okay. Also, you can isolate some, let's say, parcel of soil. Okay, what you see here, this, let's say, strip, this brown strip all around the brown soil, contaminated soil, is a watertight insulation, okay, that avoids contamination of the soil and the water all around. And you can put your contaminated soil just like if it was a swimming pool for soil, okay, and then you carry out tilling for introducing air into the soil, and you can again inject the microorganism there, and you can draw away leaching compounds and treat them in a separate system, and so on. Okay, this is called land farming. Of course, it's not real farming, so you are not cultivating anything. Of course, you are just tilling in order to increase the amount of air mixed into the soil. And the two probably most familiar, let's say, systems are composting, and this is mostly useful if you want anaerobic microorganisms and thermophilic microorganisms to degrade your compounds. So, of course, the choice between composting and biopeeling is due to the identity of the contaminants. And if those contaminants are better degraded by anaerobic thermophilic microorganisms, composting, of course, it's better, since in this case you have heavily packed soil here, through which you can make air circulate, but not in big amounts, since it is heavily packed. Okay, and when you compost organic matter, a lot of heat is produced, and so you should have thermophilic bacteria and so on. Biopeeling has much less packed soil. What you see here as black lines are supports with holes where soil is deposited. So you have some distance between soil levels, let's say, and you have air going through those, let's say, thin sheets of soil. So this is not so tightly packed. A lot of air circulates, and of course also heat will disperse much better. So in this case, you will use mainly aerobic microorganisms and microorganic organisms that are not thermophilic, but are sensitive to heat. Again, of course, you have to give nutrients to your microorganisms, and you have to have a system in order to collect leaching from the soil that goes from up into this, let's say, filtrating layer. And it's usually it's sand, in order to put and have filtration and collection of the leachate, which is, of course, heavily contaminated. Okay, so I would say that we have seen, let's say, an interesting part of our environmental toxicology course regarding the mechanisms of contamination and a few systems dedicated to bioremediation. Okay, now I think we can say something more on the exam, And so I have a better idea of what awaits you. And first of all, okay, this is Al-Maizami, and as you can see from here, we have a first exam session on April the 11th, okay? And this will be in person in room Alberti 3. I think you don't see this this session yet, since it has been published, but it's not open to enrollment. So the exam is a written exam. Of course, probably, almost certainly, you will have the chance to carry out, to sit the exam online. As I was saying, you will be. It's almost certain that the university will allow you to sit the exam also online, according to the general rules that are published on the website. Okay. However, not every student has this chance, since you have to belong to one of those categories specified in the instruction on the website. Okay, so you have to live at a longer distance than specified amount, or you are positive to COVID when the exam takes place, and so on and so forth. There's a list of specifications that you should meet in order to be able to take the exam online, okay? And you should auto-certificate this condition. So please take a look at those conditions. I think maybe we can okay, sorry. In English, okay. Here, lessons, exams, and internships. Here, you can see here that, okay, until May 31st, 2022, the following students might be exempt from attending exams in person. International students in enrollment, so I don't think it's you. Erasmus and overseas students, and students on other mobility programs, incoming and outgoing. So some of you, if I remember correctly, are Erasmus students. Commuted students who live in a place that is more than 90 minutes far away from Rimini, in this case, okay? And students with disabilities or who are ill or in quarantine, probably due to COVID, I imagine, okay? And on the Studenti online platform, you will be able to find the self-declaration, okay? Auto-certification, self-declaration, just like you want, okay? So if you self-declare you're belonging to one of those categories, I will be notified through the Al-Maizami platform, okay? And you will be able to take the exam online, okay? Of course, you have to do this before the session, or the exam session, okay? But not too many days before, since I think it's, okay, declarations are valid 15 days and can be renewed, okay? It's quite easy. It's the university web page, okay, the main web, the home web page, the home page of the website, and sorry, in English. Okay, so right here in the home page, you can find this one, the measures adopted by the University of Bologna, and then in the upper left corner, lessons, exams, and internships. Okay, and then here you can find a green certification for those who take the exam in presence and in person, and the instruction for certification. Okay, you're welcome. So the exam will be on April the 11th. If someone will be there, I will be in room Alberti 3, okay? And we will out, let's say, a normal written exam. I will show you in a moment how is the exam organized, okay? For all the people, since the exam is quite fast, it's just 15 questions with closed answers. So the choice of 4 or 5 different answers, and you have to tick the correct one. Okay, so it's very fast. You will have, let's say, a couple of hours, but I think 1 hour is more than enough. Every one of the person in person there will be able to finish the exam in about 1 hour. Okay, so we will start at about 9, and by 10 or 30 past 10, everything is finished. Okay, and other people who need to take the exam online will take the exam with me. It is still the same exam, but it will be done online. Okay, I will show you briefly how, after we have finished with the people who are there in person. Okay, so starting from more or less 30 past 10. Okay, and also, of course, we have other sessions. It's sorry, here, okay, on June the 15th and September the 9th. Okay, but of course, I think it's more convenient for you to take this one. But of course, the choice is yours. Okay. So this is the, let's say, exam organization. Here, okay, this I have this exam facsimile. Okay, let's take this one. Okay. Sorry, no, it's not this one. It's this one, exam facsimile. Okay. Oh. But, sorry, I think it's better if we do something else. Sorry, just a moment. I will take exactly what you have access to. So, in your virtuale, at the end of the topics, you will find this one, exam facsimile. Okay. Okay. No, not. It's unstable. It's LibreOffice. It's unstable. Let's try with Word. Okay. Maybe this is better. So, Sorry. Okay, so this is what you will find if you are in person at the exam. So I will give you the paper leaf with the questions, okay? You will have, of course, to fill in your name and the exam date, okay? Please note that each correct answer is 2 points. Each wrong answer or no answer is the same, it's 0 points. So, of course, it's better if you try to answer everything, okay? Even if you don't think you know the correct answer, okay? And this is an example of questions you could find in your exam, okay? So, for example, of course, if you are in person, you simply tick one of the answers, the one you think is correct, okay? It's very useful. Very easy. If you are online, I will do exactly what I am doing right now, okay? So I will show you through sharing my desktop your exam, okay? I will write your name and the date, and I will ask you to read this question and to say to me what you think is the correct answer. And I will that fluorine is a metal, a halogen, or a noble gas. Of course, fluorine is a halogen. Okay, so I will simply highlight the answer you give to me. Okay, hopefully it's the correct one, but I will highlight any answer you will say it's the correct one. Okay, and then we will go over all the questions together. Okay, so in this case, of course, we will do every one of you online separately, while of course in person each person will take the exam together at the same time. Okay, so this is a question. This is another question: which is more electronegative between hydrogen and oxygen? Of course, you may remember that oxygen is the most electronegative element except fluorine, so of course it's oxygen. In a redox reaction, there is a simultaneous transfer of electrons from one species to another. It is true. Is it true or false? Of course, it is true. It is the definition of a redox reaction. This, unfortunately, these were two pictures, and it was the general formula of an amino acid is, but since it was an open office document, it doesn't translate perfectly, but at the exam it will be visible. Okay, so this question right now we cannot do it. What is an enzyme? A polysaccharide that acts as an intracellular messenger, a toxicant that affects the endocrine system, a protein that acts as a biological catalyst. Of course, if you paid any attention, an enzyme is a protein that acts as a biological catalyst. You can see that you have 3 answers or sometimes a true-false choice, and usually at least one of the 3 is a very, let's say, strange or not very clearly false answer, okay? Incorrect answer. In order to exert its effect on the central nervous system, a toxicant has to cross the blood-brain barrier. Of course, it is true. It is one of the main actions of the blood-brain barrier to keep toxicants out of the brain, okay? Which is the most important system for phase 1 xenobiotic biotransformation, cytochrome P450, glutathione transferase, or insulin. Again, one of the answers is clearly wrong, Insulin is a hormone, okay? And among the other two, of course, one is true, and in this case it's cytochrome P450, since glutathione transferase is a phase 2 biotransformation enzyme, since glutathione conjugation, just like the name says, is a conjugation, so it's a phase 2 biotransformation. Which elements are considered heavy metals? Cadmium, lead, mercury, arsenic, carbon, hydrogen, nitrogen, oxygen, CO2, Cn-, CO, Se, SiO2. Again, I think in this case, both B and C are clearly wrong. So in this case, you don't even have metals here. Okay, so of course those are wrong. The most important compounds involved in the acid rains phenomenon are A, B, C, D, E, F, HCl, HF, HBr, SO2, NOx. Okay, so of course this doesn't mean anything, so it's clearly wrong. These are strong acids, but not those produced in burning fuels. What is produced by burning fuels is sulfur and nitrogen oxides that then become nitric and sulfuric acids, and so acid rains. Why are chlorinated solvents toxic? They are radioactive, they are able to dissolve cell membranes, they produce reactive chlorine radicals. Okay, so this one is clearly untrue. This one is a bit more difficult, but they are able to enter and to, let's say, interfere with the work of cell membrane, but they are not able to dissolve them completely. Okay, so dissolve is the key word in this case. So the main toxicity of chlorinated solvents is the production of chlorine radicals. Which is the toxic contaminant of 2,4-D and 2,4,5-T herbicides? DDT, PCB, and dioxin. Okay, so DDT, of course, is not a contaminant, it is an insecticide. PCB are not contaminants, they are additives added voluntarily to plastics. And in fact, the correct answer is dioxin. Two common classes of compounds with endocrine disrupting EDC activity are phthalates and BPA and analogues, PAHs and heavy metals, mycotoxins and CFCs. Okay, so of course the correct answer is this one. We are seeing in the EDC topic, neither of those four groups have any EDC activity. 13 is microplastic contain toxic compounds such as reactive monomers, PCBs, both reactive monomers and PCBs. And in this case, the correct answer is C, since both reactive monomers and PCBs are contained in plastics. Glycoalkaloids are found in orange, lemon, and other citrus fruits, potato, tomato, and other solanaceae plants, parsley, carrot, and other apiaceae plants. Now, we haven't even said anything about apiaceae plants or about parsley or carrot specifically, so this is of course false. And orange, lemon, and other citrus fruits are sources of flavonoids or possibly of biogenic amines, but not of glycoalkaloids. You may remember that the main glycoalkaloid is solanin, so of course the solanaceae plants. Okay, and then the 15th, aflatoxins are thermostable or thermolabile. And in this case, you may remember that one of the main point of dangerousness of aflatoxin is that they are thermostable, so they will contaminate even cooked food. Okay, so this is the correct one. So these are, let's say, the normal questions. Okay, so if you answer correctly to all of them, you will take 2 points for each correct answer. So 15 times 2 is 30 as your grades. Okay. However, in order to give you also odd numbers, since here you can take just obtain just 30 or 28, 26 according to the number of wrong answer. In order to also have odd numbers and also the lode, you can answer an additional question. I will show you just one. Okay. For example, this one, which is the main toxic effect of trichothecenes. Okay, so you can see that in comparison to the other answer, this is much more specific, and it deals with, let's say, a second tier toxicant, so something that is not a very important contaminant. Okay, so this is supposed to be much more difficult than the other questions, and it also has 5 different answers compared to the 3 maximum for the other questions. Okay, and in this case, the correct answer is anemia and immunodeficiency. Okay, all the other ones are false, but in this case, it's much less obvious that some of them are false. Okay, so it is considerably more difficult than the other questions. Okay, and if you also answer correctly to this one, of course, to all 15 of the previous ones and to this one, you will have 30 and lode. And if you make some error, you will have an odd number, 29, 27, if you answer correctly to this one. Okay. So the 15th one is only worth 1 point. Okay, even if it is more difficult than the other, since it is the question for the lode. Okay, so is everything clear? Do you have any question, possibly regarding what we have seen today during the lesson, or regarding the exam itself? No? Okay. Okay, so as I said, you will find the exam facsimile in Virtuale, so you can download it and let's say take a look at the questions. Okay. And if there's no question, I guess this is all for good and this time, and I think we will meet again at the exam. Okay, of course, while you are studying, you can contact me at any time to ask for clarifications, for explanations, anything. Okay, if you want to ask me some question, or if you want to clarify something, to obtain more information on some topic that is especially interesting for you, please feel free to contact me at any time. Okay, I will answer as soon as I am able to. Okay. So I see there's probably no question right now. So thank you for your attention. Thank you for following me in this course. And have a good day, and see you hopefully in a short time for your exam. And also don't worry, since in the past almost everyone who took this this course and sat the exam has obtained very good marks, so more or less 30 or 28 for everyone. So it is a, let's say, quite easy exam. Of course, it's an optional exam, so it shouldn't be so hard, but I think it's interesting for you also, the topic, so probably it's easier to learn it this way. Okay, so bye bye, and see you next time at the exam.
Thank you, Professor.
You're welcome. Or if you want more information, even before or after the exam, of course. Sorry, at any time. Okay. Bye bye. Have a good day.